Okay, so now kita recorded. Let's uh, let's have a look at the new chapter, chapter 2, atoms, molecules, and ions. Okay, so we start with 2.1, the subchapter 2.1, proton, nuclear number, and isotope. Okay, so this I believe you have already learned dekat sekolah menengah dahulu. However, it's mostly revision. Let's have a look lah. Mungkin ada something yang kamu sebelum ni kurang jelas, and let's try to fix that. Okay. So the learning outcomes for this chapter, subchapter, at the end of this lesson, you should be able to describe proton, neutron, and electron as subatomic particles. This is a bit small. Let me just. Okay, so describe proton, electron, and neutron as subatomic particles. You should be able to define proton number Z, nuclear number A, and isotope. And you should be able to write isotope notation. And when we want to describe, we should be able to calculate the numbers of proton, electron, dan neutron juga, as well as charges that might be present on a species. Okay. Now, so let's have a look at the first thing, structure of atom. As we know, atom adalah smallest unit of an element. Okay, so kalau kamu ada elemen, kita tengok it is made up of atoms. Even kalau compound pun kita tengok ada molecule, molecule is made up of atoms as well. Okay, so it is the smallest unit of an element. They are made up of 3 subatomic particles. Okay, so dalam atom itu, particles ni zarah. Okay, so ada 3 subatomic particles. The first one is proton, second one is neutron. Okay, and the third one is electron. And kita tahu proton ni dia terletak dekat proton dengan neutron, dia terletak di tengah-tengah atom yang kita panggil sebagai nucleus. It is packed in dense core. So kalau kita tengok dekat sini, okay, so kalau kita ada atom, ini dia punya, so this would be the dia punya nucleus, and then kita ada electron situ. So this is electron, this is nucleus, something like that lah. Okay, so this is like the kind of drawing yang sebelum ni kamu pernah buat dalam structure Lewis dahulu. Okay, so it is secara simpelnya dia macam ni, tapi it actually doesn't look like this lah. Nanti you will have a look later on in the following chapters how they look like in real life. Okay, and then so dekat tengah-tengah ni sangat mampat ya, nucleus ni ada proton, ada neutron, and then kita ada electron yang move around the nucleus rapidly in a specific region called orbital. So kamu pernah dengar perkataan orbit ataupun petala dahulu waktu sekolah menengah. Okay, so electron kita tak letak dalam orbit, kita letak dekat dalam orbital sebenarnya. This is the term that you should get yourself familiar with lah. Kita panggil dia orbital. This is something new for you, maybe something new. Mungkin kat sekolah menengah tak pernah disebut lagi. Okay. Okay, now structure of an atom. Kalau kita tahu structure of an atom, okay, ni tadi saya lukis secara kasar tu lah. Okay, so nucleus tu dia sangat kecil dan sangat mampat dekat tengah-tengah tu. Okay, so dia sangat mampat dekat tengah-tengah tu, ada proton, ada proton, ada neutron. And then kita ada kawasan yang kat luar tu kita panggil sebagai electron cloud. Okay, kemudian dia electron cloud ini dia ada macam sempadan lah, di mana elektron boleh dijumpai dengan kebarangkalian sampai 5%. So kita tahu elektron ada dekat luar nukleus. So dia akan bergerak secara laju lah kat luar ni. Okay, dia akan bergerak dekat dalam kawasan electron cloud ini. Dan kebarangkalian untuk kamu jumpa elektron dekat dalam kawasan ini adalah 95%. Lagi 5% mungkin ada dekat luar tu lah. Okay, so we will look into this further dalam chapter seterusnya. So ini adalah secara umum saja. So proton ini dia mempunyai charge positif. Okay, so it has a positive charge. Manakala neutron pula tiada charge langsung. Dan elektron seperti kamu tahu dia mempunyai charge negatif. Okay. Ini adalah master orbital, region with probability of finding an electron. Ini adalah definition orbital. Nanti kita akan tengok lagi sekali orbital ni dalam chapter 3. Sorry, dalam chat tempat. Okay. Right. Okay, so now let's have a look at the next slide. Okay, so dekat sini saya ada properties of subatomic particles. So elektron simbol dia adalah huruf E kecil. Proton adalah P, neutron adalah N. Kadang-kadang particle simbol ni untuk elektron kita tulis E negatif. So sometimes we write it down as E negatif juga pun boleh. Okay. And then jisim dia kalau kita tengok the mass of the subatomic particles, okay, neutron and proton has similar mass which is 1.67 times 10 to the negative 24 gram. So it is very light. However, electron, it's even more light compared to proton and neutron. It is 9.1 times 10 to the minus 28. Negatif 28. Sangat ringan, sangat kecil. Kalau kita bezakan antara elektron dengan proton, jisim elektron dengan proton ni, elektron punya jisim adalah 1/1840 jisim proton. Okay. Manakala charge dia pula dalam unit coulomb, okay, electron mempunyai charge, so it has a charge of negative 1.6 times 10 to the minus negative 9 coulomb, and proton has positive 1.6 times 10 negative 19. Okay, however, using this charge in chemistry, it's not that helpful, so we use the term relative charge instead. Okay, so charge secara perbandingan. So this is negative 1, electron is negative 1, this is positive 1. Okay, so charge of electron is negative 1, relatively negative 1, this is relatively positive 1. And neutron has a 0 charge. Okay, so proton number Z and nucleon number A. So proton number, symbol dia adalah Z. The proton number of an element, Z, is the number of protons. Ini adalah definition ya. Definition of proton number. Okay, so this is the definition of proton number. Proton number is the number of protons in the nucleus of an atom. It is also known as atomic number. Selain daripada proton number, dia juga dipanggil sebagai atomic number. What separates one element from another is the proton number. Apa yang menyebabkan sesuatu elemen itu dipanggil elemen yang lain adalah bilangan proton number dia. Okay, bilangan proton dia. Therefore, for example, as we know, hydrogen has one proton. If we add another proton, then it becomes helium. If we add another one, it becomes lithium. Okay, so that's what separates one element from another. It is the proton number. That's why they call it also atomic number, because it determines what type of atom it is. And then the next one, we look at the nuclear number A. This is a symbol. The nuclear number is the number of an the nuclear number of an element is the sum of protons and neutrons in the nucleus of an atom. It is known as the mass number. So this is the definition of nuclear number. Okay, dia adalah bilangan proton tambah neutron. So this is it. This is also known as mass number lah. Okay, because the mass of an atom it depends on the mass on the number of proton and neutron, because we know electron is too light, terlampau ringan. Jadi kita tambah 10 elektron pun jisim dia secara umum tidak berubah sebab dia terlampau ringan, tak ada kesan pun. Okay, so the next one, let's have a look at the isotope notation. How we can write isotope using a notation. An element can be written down in the form of isotope notation, whereas we have X in the middle, the big one, which is the element symbol. And then we will put the nucleon number on top. And then we will put the proton number on the bottom, on the left-hand side. And on the right-hand side, if the atom has a charge, we will put it on the top right side here. The charge of an atom. Or ion lah. Dalam situasi kalau ada charge, kita panggil sebagai ion. So, example 1. Write isotope notation for the following elements. Okay. All right. So I think, generally speaking, from what I have explained, you should be able to do this. I want you to try to do this right now. I give you 5 minutes to try. So please answer this. Saya tulis balik dekat sini untuk reminder. Okay. Mass number ataupun nuclear number sama dengan number of proton plus number of electron, number of neutron. Okay. And then for element, number of proton equals to number of electron. Bilangan proton dan elektron dia adalah sama untuk atom. Jadi these are all neutral elements. Neutral elements. These are all neutral. So I would like you to try to fill in the box, okay? What is the ringkas? And then tulis isotope notation dia. Kalau ada soalan, terus type saja. If you have any question, just type terus. What is A just now? Okay, so A is the nuclear number. Okay. Oh, sorry. Simbol dia kamu boleh Google uranium, ataupun kamu boleh tengok periodic table if you have it with you. Okay. Once kamu dah dapat kira tu, you should write down the isotope notation in the form of X, A, Z tadi tu. So you have to write down in this form. Dah kira semua tu, write it down as this form. Kejap lagi kita discuss. Z itu adalah proton number. Z is proton number. So information yang kita pakai dekat dalam ni sebab dia punya. Oh, lagi satu, you have to make sure tengok dekat electrons Sorry, this is not neutral. Saya buat perasan, this is not neutral. Sebab kalau kamu tengok ada number of electrons kat sini mungkin berbeza. Okay, number of electrons may be different. Okay, Mahdidan. Okay. Ada yang tak siap lagi tak? Rasanya sepatutnya you should be able to finish it already. Okay, so let's have a look at the answer. Okay, at the solution. Okay, so the first one, kita tengok uranium. Okay, so the first one kita tengok uranium. Apa ni? Alright, so the first one is uranium, A. Uranium. Uranium simbol dia adalah U. Dia bagi proton number 92. Okay, dia bagi proton number dia 92. Neutron number dia bagi 140. Okay, so dia bagi tahu neutron number dia 140. So kalau 140, kita tambahkan dia dengan proton, 140 tambah 92, we should get 232. Okay. Kita dapat 232. And then dia bagi tahu, so this is the nuclear number. So this is the nuclear number. And then dia bagi tahu number of electron dia juga adalah 92. Therefore it has zero charge. So number of neutron, number of proton equals to number of electron. Jadi zero charge. Kalau kita tengok B pula. Kalau kita tengok B, dia bagi manganese. Manganese has a symbol of Mn. Now, dia bagi tahu neutron number 30. Dia bagi tahu nuclear number 55. So we can put 55 straight away. Dia bagi tahu nukleon dengan neutron. Tapi kita tak ada number of proton. So we know that number of proton peak ni kita boleh dapat daripada nuclear number. We can get it from nuclear number minus the number of neutron. So it is 55 minus 30. We should get 25. Okay. And again, number of electron dia sama, therefore it has zero charge. Whereas C pula, okay, untuk C pula, untuk C dia bagi tahu bromine, Br, it has the proton number of 35. Okay. Number of neutron is 44. Therefore, the nuclear number is 35 plus 44. You should get 79. However, here the number of electrons adalah 36. So number of electron 36. Number of proton is equals to 35. So electron terlebih 1. Macam mana kita nak kira total charge ni sebenarnya? Nak kira total charge, okay, you should be able to think of it. Tapi kalau tak dapat, let's have a look. Total charge. Okay. Number of electron adalah 36. Dan setiap satu tu, each of the electron membawa charge negatif 1. Kita tambahkan sahaja dengan charge proton. Proton ada 35, positif 1. So negatif 36 tambah 35, kita akan dapat negatif 1. Dan kalau negatif 1, charge kita akan tulis negatif saja macam tu. Like that. So this is how we write it down. So this would be the answer. Okay. So this would be the answer. Jelas tak? Ada soalan?
Tiada, sir.
Tiada. Okay, let's proceed to the isotope notation. Okay, to the isotope. So an element can be written down in the form of isotope notation seperti yang kita tahu tadi. So this shows 3 different isotopes of silicon. Okay, 3 different isotope notation. So we can write it down as 2814, 2914, 3014. So if we look here, the nuclear number for the first one is 28, 29, 30. They are all still silicon because they have the proton number of 14. 14. But the mass number ataupun the nuclear number, they are different. All these 3 isotope notation shows that silicon has 3 different forms. And these forms is what we call as isotopes. Okay, so silicon has 3 different isotopes. this silicon isotope ni, this isotope notation can also be written down in the form of ayat like this, silicon-28, because it has 28 nucleon number. Okay, now let's have a look. Let's refresh your memory about what isotope is. By definition, isotopes are two or more atoms of the same element with the same number of protons but different number of neutrons. Okay, so two or more atoms of the same element. If we look here, these are all the same element. Proton number, they are all the same. Nuclear number, they are different because the number of neutrons are different. Okay, the number of neutrons are different. Here on the first one, the neutron number for the first one. Okay, so this is 28 minus 14. 14 neutron, this is 15 neutron, this is 16 neutron. Atoms of the same element, so these are ketiga-tiga ni, there are three atoms here, representing three atoms of the same element silicon, same number of proton, different number of neutron. That's the definition. Okay? But different number of neutrons or nucleon number. Okay? Kenapa dia tak ada ni? Okay. Alright. This also means that isotopes of the same element have different mass due to the differences in mass number, nuclear number. Bermaksud isotope have different mass. Okay? Isotopes has different mass. If you remember, kalau kamu ingat lagi mass chlorine, mass, okay, atomic mass of chlorine, ataupun relative atomic mass of chlorine, Cl, so weird. Okay, so mass of chlorine, as you know, is 35.5 kan? Okay, so this is the mass of chlorine, relative atomic mass of chlorine. 35.5 because chlorine has different isotope. Okay, chlorine is composed of isotope 35 and 37. Yes, sorry, 36 and 35 and 37, yes. So chlorine is made up of chlorine 35, chlorine 37. Okay, these two have different mass. Okay, so they have different mass. Okay, so they have different mass. Okay, and because of this, kalau kita tengok the average mass, kita campur dua ini nanti, kita kira average ni kita akan dapat 35.5 because of the amount lah, but we don't do that in this SSC calculation of the isotope punya mass. Okay, right. So now let's proceed. Okay, so this is the isotope. Okay, nuclear number semua that all lah. So untuk kita tengok 2.1 ini, so we have seen isotope notation. Okay, we have seen how to calculate the number of the subatomic particles. We know how to write it down. You should be able to know the definition of proton and nuclear number. Okay, with that said, kejap lagi kita akan proceed dalam 2.2. So for now, saya akan stop dahulu this recording. Saya bagi kamu exercise. Kalau kamu tengok dalam telegram kamu tadi, I have given you checkpoint 2.1. Okay, so checkpoint 2.1, I would like you to answer checkpoint 2.1 sekarang Okay, jawab. Kejap lagi kita akan discuss at 9:30. 9:30. Okay, so let's stop the lesson for now. Okay, so let's stop the lesson for now. Okay, okay, so let's stop the lesson for now. And I will continue the lesson kejap lagi ya. Okay. Kalau definition isotope saya tulis have same number of proton but different number of nucleon. Dia bukan number of nucleon. Dia terma number of nucleon salah. Dia perkataan nucleon number. Okay, nucleon number. But it is best to use number of neutron instead sebab kita nak specify the subatomic particles yang berbeza itu. Nucleon number tu betul, tapi it's better untuk kamu jawab guna perkataan number of neutron because we are describing the subatomic particles. Nazwa ya, 2.1 sahaja dahulu, kejap lagi 2.2 tu later on. Okay, kejap lagi dalam 8, kejap lagi dalam 9.30, 9.45 macam tu kita continue for the next part of the lesson. And before saya end the lesson, tadi definition tu kan, apa tadi saya sebut saya lupa, two number of atoms. Okay, kalau kamu tengok definition dia tadi, saya type mana definition, okay, so definition dia two or more atoms of the same element with the same number of protons at different. Kalau kamu tengok dekat sini, okay, dalam definition yang saya dah tulis dalam chat tu, here benda yang penting dia two or more atoms tu, itu penting ya. Here the grammar is very important sebab plural dan singular dia membawa maksud yang berbeza. Isotope bukan satu atom saja. Kalau elemen tu ada satu jenis atom saja, kita tak panggil dia sebagai isotope lah, kita panggil sebagai atom saja. Tapi bila kita bandingkan dua, dia ada dua bentuk. Itu baru kita akan gunakan terma isotope. Okay, so two or more atoms of the same element. This is where semalam siapa dia tanya saya, I think it was Caesar kot. Yesterday kamu tanya saya kan, grammar kalau jawab soalan, grammar tu penting ke tidak? Usually tak penting, tapi in definition like this, okay, plural, it must be in the form of plural sebab dia menunjukkan lebih daripada satu. Okay, kalau kamu tukar je singular, then dia bawa maksud yang lain. Alright, so that's all. Yes, asalkan tak mengubah maksud. Yes, kalau ayat kamu tak ubah maksud, then tak ada masalah. But here, dalam definition isotope, dia melibatkan bilangan. Jadi kalau kamu buat dalam bentuk singular, then dia jadi salah lah. Sebab isotope dia wujud dalam dua ataupun lebih jenis atom dia. Okay? Alright. So that's all. Let's continue pukul 9.30, 9.40 macam tu. I'll check kalau kamu boleh siap kata. Okay, so thank you. End the recording now. Kamu boleh leave dulu. You can leave the ini